Hello, my name is Ali Dunning, and today I will be explaining the process of nodal analysis. A node is a point in a circuit at which two or more branches intersect. Nodal analysis is the calculation process which allows the voltage at a node or nodes to be determined. There are two important theories that you should know before attempting nodal analysis. The first one is Kirchhoff's current law, which states that the current into a node equals the current out. This can be represented in this diagram as I equals I1 plus I2. The second theory you should know is Ohm's law. This states that voltage equals current times resistance. There are 4 stages involved in the nodal analysis process. Step 1. Count and label all nodes on your diagram. Step 2. Label current directions and polarities on each of your nodes. Step 3. Apply KCL to each node with an unknown voltage. Step 4 is solve all your KCL equations using Ohm's law. Now it's example time. When looking at this diagram, our first step is to label all nodes. We have labelled the bottom node that is attached to the ground as V0, which equals 0. This is our reference node. Up the top we have V1 with an unknown voltage, and over here we have another node with a known voltage of E volts. In order to complete step 2, we must label the current directions on any unknown nodes. We can therefore look at only V1 because this is our only node with an unknown voltage. We can see that there will be current flowing into this node here and flowing out through this branch and also out through this branch. For step 3, I have indicated the current flowing in as I1 and the two currents flowing out as I2 and I3 respectively. For step 3, we use KCL and we say that the current flowing in is equal to the current flowing out of a node. When looking at V1, we know that the current in, I1, is equal to the current flowing out, which is the sum of I2 and I3. For each voltage component, we must subtract a final voltage from the original voltage for each current value. For example, to find I1, we subtract V1 from V2. That completes the voltage for I1. We then divide it by the resistive component of which it passes through between these two voltage values, which is R1. We can then complete this step for the next two current values, I2 and I3, using the same method. The voltage for I2 is V1 minus V0 divided by the resistive value R2, and respectively for I3 it is also V1 minus V0 divided by R3. We can now sub in our equations for our currents back into the original equation, however now they're in terms of a voltage and a resistive value. Finally, to solve for V1 we must rearrange our equations to make it in terms of V1. Therefore, by using nodal analysis, we can now determine a value for V1.
Like and subscribe below for some more great content. Thanks for watching.